took most of them drank all my wine.
All right, well, today we are going to look at adjacent and vertical angles. We are now beginning our chapter on angle measurements and angle relationships. That's the main idea of this chapter. So again, this specific section is covering adjacent and vertical angles. And so let's start off with a little bit of a review. I think a lot of you have probably learned about some different special type of angles. And we're going to look at 4 specific type of angles. We have first an angle that's called an acute angle. Acute angles, like their name would suggest, these are smaller angles. Specifically, these are angles that are less than 90 degrees. Of course, they're greater than 0 as well. The next angle type we have are exactly 90 degrees, and they're only 90 degrees. These are called right angles. And we can identify them with a little box inside of the angle, a little square. That's how we identify it being a right angle. If you see the little box there, you can assume that the picture is supposed to be displaying a right angle. Now, if you have an angle that meets these 2 criteria, number 1, it's greater than 90 degrees. And number 2, it's less than 180. Then you have yourself an obtuse angle. Obtuse is greater than 90, less than 180. And then finally, an angle that is exactly 180 degrees, this is considered a straight angle because it makes a straight line. Okay, so moving on, we're going to have 2 different types of angles we're going to look at today. One is called an adjacent angle, or adjacent angles, and then the other one is vertical angles. Okay, so let's go ahead and start off with the adjacent angles to begin with. So with adjacent angles, you probably have heard the term adjacent at some point, maybe not in math, but just in general life. You may have heard someone talking about, my room is adjacent to someone else's room. What that means is that if you have a room that's adjacent to somebody else, it means that there is a common wall that you guys share. And in math, it's the same thing. When you have 2 angles that are adjacent, all that means is that they share a common side. And if they share a common side and they share a common vertex, they are considered adjacent angles. Now, I've used a couple terms here. Let's take a look. The first thing is a vertex. Now, a vertex starts off just as a point on a graph. And from that point grows 2 rays, which creates an angle. And that point that it all started with, this is called a vertex. All right? Let's go ahead and continue with this. So when we have 2 angles that are adjacent, we're going to look to see, do they have a common side? So in our example here, you see that there are 2 lines that intersect. And when these 2 lines intersect, they formed 4 angles. They named them 1, 2, 3, and 4. Now, you can also do it this way. Let's say that I have these 2 angles that intersect. There's 2 lines that intersect that form angles. And again, as you can see, it forms 4 angles. And I'm going to go ahead and put a point up here, a point right here, a point here, a point here, and a point here. And we're going to call this A, B, C, D, and E. So there are 2 different ways you can name angles. Again, that's a C up top. One way is you can name them by their numbers, if each angle specifically has a number. So I can say, let's look at angle 3. What is an angle that is adjacent to it? So with angle 3, it has 2 sides. That means an angle on either side could be the adjacent angle. And so, for example, let's say this angle right here, well, this side right here, that is a common side, and so we know that angle 4 and angle 3 are adjacent. We also know that angle 1 and angle 2 are adjacent because they share a common side. It's like right here. And then you see over on the next one, angle 2 and 4, these are directly across from each other. They are not adjacent because they do not share a common side. They don't share any sides in common. They share a vertex, just not a side. So they're not adjacent. Now in our other example at the top right, let's say I look at angle right here. This one, we name it angle CBD. Now you always write the vertex, it goes in the middle. So it's CBD. And all three of these angles were included. And so there are two different angles that are adjacent to angle CBD. And we just have to look at one of them in this case. And so if I look right over here, here's a common side, and so the angle that it's adjacent would be angle DBE. And I want you to notice that in the first angle, we had angle BD, and over here we have DB, which is the same thing as BD. And so they have a common side, DB or BD. And so therefore, they're adjacent, or at least that's an indicator. Or put it this way, they cannot be adjacent unless they have one side in common. That means when you're looking at two different angles, if you're naming them by their points, they have to have two of the three letters need to be the same. Okay? And one of them, of course, would be the angle. The vertex, the vertex. Now, the other type of angles we're going to deal with are called vertical angles. And, when you create, when you have two lines that intersect, like right here and right here, the same thing happens every time. The first thing that happens is you have four angles that are created when two lines intersect. The other thing I want you to notice, in this case we have two acute angles that look like they're the exact same measurement, and that's because they are. We have two acute angles that are the exact same. And then we also have two obtuse angles that are the exact same. They're called congruent angles. And so these are what vertical angles are. When you have two lines that intersect, they form pairs of angles that are across from each other, that are congruent with each other. And so typically we're looking at a pair of acute angles or a pair of obtuse angles. However, it is possible that you could have all four angles be right angles, and it would still be true. But the key thing is the angles that are across from each other are the vertical angles. Okay, they're opposite angles. Again, formed by the intersection of two lines. So in this example to the left, you'll see that angle 1 and angle 3 are across from each other, and they're both obtuse. Therefore, they are vertical angles. And then we see that angle 2 and angle 4 are two acute angles that are across from each other. They're opposite. Therefore, they are vertical angles. 2 and 1 are not vertical angles. They're adjacent. Just as in 4 and 1, they're adjacent. All right. Moving on. Okay, well, in this example, we are to name a pair of adjacent angles. And so we're going to look at first the example that is given to us. So we have angle ABC, which is right over here, this angle here, ABC. And it has two different angles that are right next door to it. We have one to the left, one to the right. The one to the left is angle A. The one to the left is angle ABE, and the one to the right is angle CBD. And the ABF one right here, the green one, that is the one that's right over here. So angle ABC and angle ABF, these share a common side and have a same vertex B. Therefore, they are adjacent. Now, as well as that, you also have angle, I'm sorry, let me do it this way. You also have angle ABC. And you have angle CBD. So these are also adjacent angles. There's several more to choose from, but here's a couple. And then we had to name a pair of vertical angles. So with the vertical angles, let's look at what we were given to begin with. So it says angle ABF. So ABF, which is right here. Now keep in mind, when we're doing vertical angles, we want to find out what lines intersect. So I have AB or AD, this line intersects with this awful crummy looking line that I did. Not very good. I know. So I see that ABF is an acute angle. The other angle that is acute, there's only one of them, and it's right over here. That's angle CBD. And so that is right here. So these two are on opposite sides of the angles. They share a common vertex. They are congruent. Therefore, they are vertical angles. All right. So your job is to identify two pair of adjacent angles and two pair of vertical angles. I'm not going to name them all. I'm going to go over a couple of them, and then you can see how you did and see if yours match up with any of the ones that I came up with. But just because they don't match up with mine don't mean, this doesn't mean that they aren't adjacent or vertical. Just means I'm not going to write down every single pair because there's several. All right, so take a moment and see what you come up with. Okay, let's go ahead and begin with our adjacent angles. So I have angle, we'll say this one right here, VWX. So angle VWX. And it goes with angle, you could either say the one right here or the one right here. Either one of those work. I'm going to go to the one with the right. So it goes with angle XWY. Although you could have done VWZ, it would have been just fine. The other one we have, or another one we have, I guess, is you have, we'll go in the opposite, we'll say this, we'll say VWZ. This angle, and again, I could say VWX, but I'm going to go ahead and do ZWY because they share this common angle. So angle ZWY. And again, I want to point out that with these two angles I just showed you, we have WZ and we have ZW. They have a common side. The one before that, we had WX and XW. They have a common side. Now, when dealing with the vertical angles, again, I have this line and this line. Oops. That are intersecting lines. And so I have, we could say, these two angles are vertical. So I have angle VWX and I have angle ZWY. And then I also have these two angles. You'll notice that I put one line or one arc for the reds and two arcs for the blues. That shows you the one with the two arcs matches up with the other one with the two arcs. And the one that has one arc matches with the one that has one arc. That's why they do that, to show congruence of angles. So I have angle XWY. And I have angle ZWY. These are vertical. My other adjacent angles for the other problem here. Again, there's a bunch of them. I'm just going to look at a couple of these. So I have PJQ. We'll start with that. PJQ, angle PJQ. And that line, we could say it goes with, here's a line that it has in common with its next door neighbor. We'll say QJK. That's one pair. And then let's say that I am going to look at, I don't know, angle NJM. And, well, NJM, we'll say NJ is our side that we have that is adjacent, a common side. So we're going to say PJN, angle PJN. These two are adjacent. All right? I'm going to go ahead and continue this line all the way across. And then I have a blue one. We'll continue this all the way down. And then I have a red one. It goes this way. These can be confusing. I like using colors. Colors make it easier, I think. So let's look at two different sets of vertical angles. So what should we do? All right, let's do this. We're going to have angle PJQ. Angle PJQ. And, well, this is red to blue, so we're going to do red to blue. See how easy that is when we're doing colors? So we're going to do MJL. There's one set. And I'm going to use red for the other one. And we'll say, I'm going to do blue to green. So I'm going to say QJK. Angle QJK. And angle NJM. Okay, these two are vertical. There's others to choose from, but I just want to give you a couple. Let's move forward. Next, we can identify whether, or the directions tell us to please tell whether the angles are adjacent or vertical, then find the value of x. So for A, we can look at both of these. They are across from each other. They back up to each other. That makes these vertical. Since they are vertical, if one angle is 70, then x must also be 70. That's an easy one, right? The next one's a little bit more tricky. They share a common side, therefore these must be adjacent. And we have to be a little creative with this. We want to find what x is, and we know that these are adjacent. And we know that they are both two angles that when added together, they equal the bigger angle. And we know this bigger angle has a red box here. Therefore, it is a right angle. So combined, they equal 90. So I have 31 plus x plus 4 equals 90. Therefore, I have 35 plus x equals 90. Therefore, I can subtract 35 from both sides. And I have x equals 55. So there's your work there. And that's the work I expect to see. The last thing, This is going to be tough for me to show on the iPad, so I'm not even going to try. I'm going to explain the best I can. As you know, most of you learn this in class. I'm just putting this as a backup for you. But I will explain it as best I can. The way that we're going to draw a pair of vertical angles using a protractor that measure 40 degrees is this. The very first thing you do is you're going to draw a vertex. And then using the straight edge of your protractor, you're going to draw a straight line. And once you do that, you're going to place your protractor on top of that straight line. You're going to see that in the protractor, there's a little opening and it has a line on either side. That little opening should go over the vertex. And then those lines should match up with one of your lines, depending which direction it's going. That way you have it lined up. And then you're going to have to look at your protractor, and you're going to see that 40 shows up twice. There's a 40 over here, and there's a 40 over here. And we know that our first line is starting on the far bottom right-hand side of the protractor. So does it make more sense that it's going to go to here? Or does it make more sense it's going to go all the way over here? Obviously, it's the first one because an angle at 40 degrees is small. It's less than 90. And so therefore, it's going to be right there. So you're going to do this. I draw a little marking right above where that 40 is, and then I use my protractor as a straight edge, and I draw from that marking to my vertex, which is right over here. And then I use that straight edge to make that line. Now, the second part, very easy. We're just going to extend the lines. And so I could just, with that straight edge, I could just continue this all the way across, and then I rotate it, and I'm going to extend this all the way across. And that's all you're really doing to get our final product. Hopefully that makes sense to you. If not, see me in person. We can go through it together. Okay, so we are down to the very end here. I want you guys to do number 3, 4, and 5. You're going to do that, and then I'm going to go over these with you. And then the last one, number 6, I'm not going to do that one on here because I don't have the tools needed to do this, so I'm not going to worry about this one. But we'll check that one in class together, okay? So let's go ahead and just look at 3, 4, and 5. And you guys give this one a try. All right, let's see how you came up, how you did with this one. So we're told to identify whether these are adjacent or vertical, and then find the value of x. So for number 3, you can see that we have a straight line. One is 85, the other one is unknown. And since it's a straight line, they can't both be 85 in this case. And so they are adjacent because they share a common side. So these are adjacent. And what we know is that we know if we add 85 plus that x, it's going to equal 180 because it's a straight line, a straight angle. I'm going to subtract 85 from both sides, and I get x equals 95. So there's your value of x, and it's an adjacent angle. Now, for number 4, the way they have it set up, these angles are across from each other. They are opposite sides of each other. Therefore, these are vertical. And since they're vertical, we know that x must equal that red box, which is 90 degrees. So it's x equals 90. Number 5, it's an easy one. It's just like the example we did a few moments ago. For this one, these are adjacent once again because they share a common side. They're adjacent. And this is what we know. We know that the two angles together equal 90. So I have 69 plus 2x minus 1 equals 90. I know it looks weird, but that's exactly what you write. The two angles added together equal 90. And then I'm going to combine 69 and minus 1, which is 68, plus 2x equals 90. I'm going to subtract 68 from both sides. And I get 2x equals 22. Divide both sides by 2. I get x equals 11. So there you go. Like I said, we'll go over number 6 in class together. I hope this was helpful. Best of luck. We will talk to you soon.